Hi everyone, I'm excited to give you my pitch today about my project on long-term wind speed forecasting using machine learning methods. So the total renewable energy generated at a wind farm is directly proportional to the cube of the wind speed. So it is important for a wind farm developer like WindLab to have an accurate prediction of the long-term distribution. So wind speed follows a Weibull distribution and it looks something like this graph. And when a potential site is identified, a short-term wind measurement campaign is started, and then this short-term data can be combined with long-term reference wind speed datasets from nearby wind stations in a meaningful manner to get you the long-term Weibull distribution at the target site. Think of it like predicting this wind speeds at ANU by combining the airport, Belconnen, and Gangalen together. So there are many ways to build this, but in general, we build a mapping function between the target and the reference series over the coincident time or the overlapping time period. Then we apply this full mapping function over the long range time series to get our long-term historical distribution. So quantifying uncertainties is one of the key challenges of this modeling process. And some methods can give us slightly inaccurate answers, but reasonably certain, whereas some other methods might be relatively correct, but very not confident about their estimate. And the Bayesian neural networks try to get the best of both worlds. BNNs give us this useful model where the uncertainty is baked right into it. Instead of learning distributions of weights, they learn point estimates of weights. Instead of like A is 2 times B, A is sometimes 1.95 times B, sometimes 2.05 times B. And yeah, turns out when you take an average of this over a long number of predictions, you get highly accurate results with very low uncertainties. So overall, I researched machine learning models for BNNs for wind forecasting. I used TensorFlow and Python for programming and visualizing my model results. Later, I incorporate all of this together into a one-click script used by my WindLab colleagues now. And I will also present my technical findings to them later this week. In terms of impact and outcomes, BNNs can quantify uncertainty systematically, as well as obtain accurate and reliable predictions of wind speeds. All of this translates into cost and time savings for the business, as well as improved decision making about potential wind farm sites.